recording. At the end of every class, before we get into today's objectives and everything, at the end of every recording, the end of the class, I will ask for questions for the recorded portion, and then I will stop the recording and I will ask for questions that you don't want on the recording. So you'll have the opportunity to ask questions that are recorded for the good of the group and ones that are not recorded. So we do that at the end. A class will never last till 7:50. And I don't want to listen to myself talk for 2.5 hours. And I don't think anybody else does either. Also, you give too much new information and you're going to start losing it, start seeing eyes glazed over, and it's just not fun. So we will never go to 7:50. Occasionally, I think the latest that we ever really go is maybe 7 o'clock. We're usually done by about 6:30. So maybe 6:30, quarter to 7. So we almost never go to 7:30 or 7:50. Actually, I've never gone to 7:50, but 7:30 is about the latest you would go. And that's if we missed one Zoom meeting or something. Sometimes I have to fit extra into one, but you will not be going to 7:50. The idea of the 2.5 hour class is that you would have time. No, I'm not offended at all, Quentin, not at all. I mean, nobody wants to sit in a Zoom meeting for 2.5 hours. So I don't want to talk for that long. So yeah, I'm not going to go that late. I mean, most of them done by 6:30, seriously. And the idea of the 2.5 hour class is so that you have time to work on your homework and your labs afterwards. And usually, most of the time, I will be popping in and answering questions and things like that. When the 2.5 hour class was initially started, it was because it was in person. And generally, what would happen is I would lecture for a little while. And then while we're in the computer lab, students would work on their homework, and I would circulate and help. So I try to emulate that as much as possible. And so I am not offended at all because I don't want to sit in a 2.5 hour Zoom meeting. So I'm not going to go over the syllabus in this meeting. That was the welcome video has me going through the syllabus. I wanted to make sure that we optimize this time and I give you what you need. So before I start actually going through today's objectives and talking about content, are there any questions? Feel free to unmute yourself, or you can type in, says you can stay. I mean, you can definitely stay in the Zoom meeting to do your labs. I will give you lab instruction. Well, no, I won't stay in the Zoom meeting till 7:50. No, I will not do that. But if you're doing your lab, you can send me a message. The labs, you could do them along with me when I teach them. Next class on Thursday, I will be teaching the lab. And if you have all of your data already, you're more than welcome to kind of work along with me. But I don't stay in the meeting until 7:50 because it would be sad, it would be lonely. So I just turn it off, but I'm usually fairly available at least till 7:30. But I get up at 3:30 in the morning, so I go to bed early.
So question about labs. I know this is preemptive. I'm sorry for apologize to everybody, but are we able to do 20 data points in the lab this time, or?
Yes, you can do 20 data points. At the end of this, after I'm done with my PowerPoint and my teaching tonight, I will tell you what type of data you need for your lab. So Coral, I prefer messaging through the course messages. That's a really good question. I prefer that over email because I get so many emails every day. It's easy to get lost. It's easy for me to lose somebody through the emails. And yes, I get them quicker because they're on my phone. But when they're in Blackboard, it is much, or even through my open math. Either way is fine. So I will always answer you in Blackboard, though. I think I said that in the welcome video. But if you message me through the assignment where it says email instructor or message instructor, I will respond to you in Blackboard. I like Blackboard because I can it's easier to organize, and I know, hey, I'm answering a question specifically from this class. But if it's something that is like super important, I need an answer right now, then send me an email. But I would say not every question demand an answer right now, but if it's hey, I need this answer like within an hour. If I'm at work during the day, because my day job is, I teach math at Illinois Valley High School. So that's my day job. I keep a tab open I have a Blackboard tab open. I have my open math tab open. I have my email open. So I have all of that open and I check it frequently, all of those frequently during the day. It doesn't mean I can answer frequently, but if it's something that is really important, I will do my best to answer. I'm at Illinois Valley High School. I am out in Cape Junction.
Oh, wow.
Yeah. I don't live in Cape Junction. I work in Cape Junction. And it is really an amazing school. I love it out there. This is my 5th year there. It's my 9th year teaching K-12, so regular public school, teaching little kids. And I started teaching this is my 6th year at RCC teaching there. So, and my very first math class at RCC was stats with some of you are in Fran Gunson's co-rec. She was my stats teacher. She's awesome. I love her. Okay, so enough of that. Let's talk about it. Unless there's other questions, I'm happy to answer them.
Can you hear me?
I can hear you.
Okay, cool.
Did you
Just
have a
checking.
question or you just want to make sure I could hear you?
Well, I'm so nervous because I've never taken this class. So hopefully I'm going to see how it goes today. And if I have to drop it, I will. I need it for Colorado State University, but I don't want to be overwhelmed because I got 19 credits going on right now.
Oh my
So
goodness, that's a lot.
yeah, so I'm going to see if I can understand it.
Okay.
If I can, I'll stick with it.
There's no actual math today. Today is the boring day. Today's the
Okay.
boring day. Just letting you all know.
Okay.
The boring day means that you're getting a lot of vocabulary. There's going to be a
Okay.
ton of vocabulary today. Today's the boring day.
Okay.
One of the unique features of my class is I know most online classes, the things are due on Sunday night. Because of that, I made assignments due on Monday and labs
Yes.
and quizzes are due on Tuesdays.
Nice.
So that's, I tried to do that because I know most teachers have everything due Sunday night at midnight and
Yeah.
it makes quite a scramble. So I'm hoping that helps. So I open something on Sunday and it's going to be open it won't be due for like 9 days. Because if I open it,
Oh,
like, let's say today's Sunday, I open it this Sunday, it's not due until the Monday after next. So not tomorrow, it would be the following Monday. So you have basically 8 or 9 days to get it done.
so can I ask a question?
Yeah.
Is the lab part of it? Is that where I'm going to be able to get help?
I mean,
Or is that
you mean the co-requisite or like
yeah, co-requisite?
the co-requisite class? I'm not
Yeah.
sure exactly. Somebody else who's taken it before might have a better idea, but I do know they do some help. They also do some pre-teaching of some like algebra topics you may not have gotten in your algebra class, but they're
Okay.
very helpful. And our
Okay.
tutoring centers are amazing.
Yeah, I'll
They're
probably live
amazing.
there. Okay.
Okay. All right, Eddie, we'll see you later. Okay. So, today's objectives, we're going to do chapter 1. Chapter 1, we're going to define statistics and statistical thinking. Hard words to say. We're going to talk about the process. You are not going to have to relay that process to me. I just kind of want you to know what it's all about. We're going to talk about what quantitative and qualitative variables are, discrete and continuous. We're going to look at levels of measurement and actually we're not even doing source bias and random samples. These are not even on today, so I'm getting rid of those. And then section 2.1, we're going to look at organizing things in tables and constructing bar graphs. This really shouldn't take a heck of a long time. It shouldn't be too bad. Make sure you all ask me questions if you have them. I am happy to answer them. All right, so vocabulary. The word statistics is this is, in my opinion, more science than math class because there are processes for everything like in science. So statistics is the science of collecting data and analyzing that data and using it to find answers to questions. We also talk about providing measures of confidence. So you've probably seen things where they say like, yeah, this candidate has is projected to get 46% of the vote, plus or minus 3%. That's a confidence interval telling us that, hey, it could have this margin of error. It could be 3% higher. It could be 3% lower. That's basically what we do as statistics, is we provide a range of values that are probable, like things might land in. And we have a very meticulous way to do this, and I'm going to teach you about it, but not today. Don't worry, we're not doing math today. We're mostly today just talking about stuff. So the word data, or also data, I use both of them interchangeably, and I say them both ways. And one really weird thing is data is a plural word. You will frequently see data are, and it annoys me. I kind of can't handle that it's data are. Most of the time I will say data is, but just letting you know, data is a plural word. Data can be numerical or it can be non-numerical. Any kind of characteristics that we can find out about somebody, it's going to be our data. So we're going to try to use the data to offset anecdotal claims. We're going to prove a point, and we're going to have a lot of fun. That's kind of the idea. Hoping you all enjoy the class as much as I do. I mean, I don't know if you can enjoy it as much as I do, but at least close. Okay. These vocabulary words, you will be asked questions that require you to use these vocabulary words. So important. Oh, wait. Before I, side note, I highly recommend, if you have access to a printer, print off the PowerPoints before this class and print them like 3 to a page, 2 or 3 to a page, because otherwise you're going to have so much paper. So print them 2 or 3 to a page and take notes directly on the PowerPoint. This is going to help you because you can use your notes on your tests and quizzes.
Oh,
So you can use those notes. Printing off the PowerPoints is going to be so helpful. So just letting you know, FYI. And if I move too fast, please tell me to slow down. Sometimes I get excited and I move on. So back to the vocabulary. Back off the aside note. Population is our entire group to be studied. So it is the group as a whole. Sometimes it's something as simple as every US citizen or every, student in the US. Sometimes it's super big and broad. Sometimes it's a little bit less, but it is the whole group to be studied. And here's an example. If we were presenting a study of RCC students, we were trying to determine if there's a correlation between the amount of time studying and the grade they receive, our population would be all RCC students. So we're studying, even though we're not going to ask question every single person, our population is RCC students. The sample is a subset of the population. So the sample would be the people that we talk to. So I'm not going to question every single RCC student. So I'm going to take a sample. I'm going to question 10 or 15 students or whatever number that is, and that would be my sample. So for example, with the study above, if I took 50 RCC students and asked them about their study hours and their grades, those 50 students are our sample. So next, an individual, that's one member of the population that's being studied. Just one person or one thing or whatever. So in this case, in this study, one RCC student would be our individual. So it would just be that one individual person. All right, questions?
yeah.
I'll give you a moment to write things down if you're writing things down. All right, moving on. If you need a moment, make sure you tell me. Okay. All right, so this is in class. I generally give everybody a Post-it note and I have you write the answer down, but we're just going to kind of generalize here. So you're walking down the street, you notice that a person walking in front of you drops $100. and nobody notices except for you. Since you could either keep the money with no one knowing, or you could return the money to the owner. So if you keep the money, nobody's going to know, or you can return it to the owner. So I'm asked fictional people. Let's say I asked our whole class. We're going to pretend we have 30 people in the class. I know we're somewhere close to that. I think we're like 25 or 26, but pretend we have 30 people in our class because it's an easy number. And I questioned everybody anonymously on whether you would keep the money or return it to the owner. So I'm going to say 27 out of 30 people said that they would return the money to the owner. Because this is usually about right. That's usually about the number that I get. So that would be 90% of the people, 90% of our class. I'm having issues. Okay, let's try this again. If I set my hand on the iPad, or if my sweater brushes the iPad, it does wonky things. See, it just did it again. Okay. There's an ugly 90%. So 90% of our class would return the money to the owner. So a statistic is a numerical summary of a sample. So we took a sample of all RCC students, took a sample of 30 of them, and I'm just summarizing. I'm not doing anything with this data yet. All I did is summarize it. So I took a sample of 30 people and I questioned them, and I got that 90% of that sample would return the money to the owner. So a statistic is just a numerical summary of a sample. I remember statistic and sample because they both start with S. That's how I remember which is which, other than the fact that I've been teaching this a while. So descriptive statistics. So if I took those statistics and I described them away through a summary, a table, or a graph, this would be descriptive statistics. I am not going to ask you to come back and tell me what descriptive statistics are, but I will ask you what a statistic is. So it's important to know that a statistic refers to a sample. Important. I'm going to have a page at the end of this that summarizes the other word that I'm going to give you also, and you'll so you can put them both together. Okay. So we described the results without drawing any conclusions. That is descriptive statistics. Let's move on. So once again, we're at 27 out of 30. So 90% of our class would return the money. Inferential statistics. Now, if I took this and I applied it to the population, so if I said that since my sample, 90% of the people would return the money to owner, if I am inferring that 90% of all RCC students would return the money to the owner, that would be inferential statistics. So when I take it and I apply it to the whole school or the whole population, then it's inferential. I'm making an inference. Integrity test, exactly. I know. So I usually have one or two people that say that they'd keep the money. And it's funny though, because when I ask this of high school students, the number of people who would keep the money is a lot larger. I know it's not really a surprise, but we're usually more at 75, 80% when I ask high school students. Okay. So if we are making an inference about the whole population, I'm going to have that level of confidence. I need to have a margin of error. Because I can't sample the entire population, I need to calculate a margin of error. Don't worry, you don't have to do that today. That's like, I don't know, week 8 or something. So no worries there. So we can say that all RCC students, I can say with 95% accuracy that between 87% and 93% of all RCC students would return the money. So I have that margin of error of about 3%, and I did not calculate anything. I just guessed. I just made it up. So don't ask me, you don't have to say, where did those numbers come from? I just made it up. I just went 3 below 90% and 3 above 90%. I didn't use all my analytical craziness yet. We will do that like week 8. So if I was inferring, I would have to have that margin of error, which is 3%, and I need to say how accurate my guess is. And we'll talk about all that later. Right. So suppose the percentage of all students on your campus who have a job. So any questions here before I move on?
You know.
Okay. So suppose the percentage of all students on the campus who have a job is 84.9%. This value represents a parameter. Woo, a parameter because it is a numerical summary of a population. So parameter, population, P and P, statistic, sample, S and S. So if we are talking about an entire population, it is called a parameter. If you're talking about a sample, it is called a statistic. I think I'm going to have both of those in a minute. So here, 250 students, we took a sample of 250 students. We found 86.4 of those 250 have a job. So this is a statistic because it is a summary based on a sample. So here's my putting it all together. This is important. You will be asked this question. And I can say with a lot of confidence that there might be one question on the test that requires you to talk about a statistic and a parameter. So they will ask you, and I know the homework assignment does, it asks you to, they'll give you a scenario and you have to determine if it's a statistic or a parameter. All right, I move on. Anyone need a moment?
No.
All right. Okay. All right. So you will not need to reiterate the process of statistics. I just am going to kind of give you, this is how it works. This kind of will show you that it's very sciencey. So if you're somebody who likes science, stats might just be the math for you because we are more sciencey than mathy, in my opinion. So the first thing you do is why is it being slow? Hold on a second here. My internet,
Sorry.
my being slow.
Can you hear me?
Yeah, I can hear you.
Okay, I actually had a question. I just looked at my notes, differencing between the statistic and the parameter. So all the ones on the homework, the questions, those ones I got pretty easily, as well as the example you just gave us of where you listed the RCC versus the class. But is it helpful not to look in the book because the questions that they asked, like, I suddenly got really confused.
So the questions, I feel like the book is confusing sometimes.
Okay.
Sometimes you can get more clarification, but sometimes it's kind of confusing. If you got the ones in the homework, fine, you're fine. And I don't know why this is not showing what I have on my iPad. It is really, I'm going to unshare and then reshare because I'm having issues. Sometimes my internet just decides to slow down a little bit and it's still not there. What the heck? I'm going to unplug my iPad and plug it back in. I may have to pause my recording if I can't do nice things. Sometimes it just doesn't want to be nice to me. Okay, let's see. Okay, I'm going to pause my recording and we're going to fix this. Resume recording. All right, we're back to recording. Okay, so the first thing we do with the process of statistics is you figure out what is my question? What am I trying to answer? Before you even collect any data, you have to figure out what question you're trying to answer. Because if you don't know the question, you're just going to be collecting random data and you're going to be like, I have no idea what's going on. Let me just collect all this stuff. However, there's a lot of times I'll see some data and I'm like, ooh, that's interesting. Let me do this to it. Let me do that to it. So that does happen, but basically you start off with your objective. Then you will collect your data. Now, you generally cannot poll an entire population. So we are going to learn some math later on so you can figure out what sample size you need. And you need to collect it correctly. So you need to make sure that you're using like a random sample. You need to make sure that you're not asking the questions to people who you know or what answer they're going to give. For example, you're not going to post a poll on Fox News asking if people like Donald Trump. because you know what's going to happen. Or you're not going to post a poll on MSNBC and ask them if they like Donald Trump because you know what the answer is going to be. So if you're in a place where you know the way the people are going to answer, like the convenience sample is what it's called, or you need to actually have your sample be people that are random. Like I could randomly choose people off the street or randomly choose people out of a hat. So it's very easy to skew the results by asking the question in the wrong place. You're not going to go to the gym and ask people if they're health conscious. Guess what they're going to say? Because they're in the gym. So, I mean, I'm not going to go into a room full of teachers doing professional development and ask them if they thought that education was important. I know how they're going to answer. So you need to be careful when you're asking your question that you're trying to be random. Now in this class, the project that we do and the labs that we do, I'm not going to be a stickler about that because it would be pretty hard and time consuming for you to truly make it nice and random. So just be aware of the way it should be. Let's go with the next one. So as I just said right here, many studies are based on convenience samples. They do internet surveys or phone-in polls, things like that. They're not super reliable. So describe the data. So before you're first, you're going to like talk about what answers you got, or you're going to talk about, here's what my data is. Here's this percent. You're going to do all of the math to it and you're going to describe it. You might be using some tables. You could be using graphs. You could be using all sorts of pretty stuff. But here is where you're trying to crunch some numbers and figure some stuff out. And then here afterwards, after you've done all your numbers and made it all pretty, now you make your inference. Now, once you've used the appropriate techniques, which you will learn later, you can apply it to the entire population. Now you can say, 90% of all RCC students, I believe 90% of all RCC students will give the money back plus or minus 3% or whatever. This is your inference. This is where you apply it to the population. And though it's not on here, number 5 would technically be like your conclusion, where you can write up your paper saying, this is what I'm concluding based on this. And then most of the times people perform the study again, because that's what happens. Once you get a study and you're like, hey, this is a really great study, they're like, okay, do it again and see if you get the same thing, because you need to replicate it. Anyone who's taken science classes, once you get something, come to a conclusion, you have to see if it can be replicated. And it's never ending. All right. You're not going to have to repeat this to me. I just wanted you to have an idea of how things are done. Any questions so far? Are we doing okay?
Yeah.
All right, good. Okay, here's an example. Okay, so I really need a new example because I get really tired of saying batterer, the word batterer, but this is the example I have right now. So there are a lot of studies to determine if to find batterer treatment programs. So a person who batters their partner is assaulting them. So this experiment is comparing a batterer treatment program to non-therapeutic treatment, which is community service in this case. So the researchers have an experiment. They took 376 male criminal court defendants. They were accused of assaulting their intimate female partners. They were randomly assigned to either a treatment group or a control group. In the treatment group, they entered a 40-hour batterer treatment program. Then the control group received 40 hours of community service. After 6 months, 21% of the males in the control group battered again, while 10% of the males in the treatment group had further battering incidents. The researchers concluded the treatment was effective in reducing repeat battering offenses. So what we're going to do is we're going to break this apart and we're going to look at each piece so we can see how it fits into our statistical method. We're kind of like a scientific method. All right. So identify the research objective. That was number 1. Our research objective is we're trying to determine whether the treatment program is more effective than community service. This is what we were trying to do. Step 2, we need to collect the information we needed to answer. So the way we did that was we randomly assigned 2 groups, one to batterer treatment program and one to community service. And then after 6 months, we took a look to see the percent that battered their intimate female partner again. Describe the data, organize and summarize. So after that 6 months, we noticed that 21% of the males in the control group had further battering incidents, while 10% in the treatment group had further battering incidents. So notice I didn't apply this to anything. This is just me saying, this is what we noticed. This is what we saw. Step 4 is where we can draw our conclusions. We extend these results of the 376, and because of this, we determined that those who are in the batterer treatment program are less likely to batter again. That's the conclusion that we drew from the data. That makes sense. I'm not going to ask you to break this down in any of your assignments. I just want you to recognize it. This will be important though. This vocabulary, we like vocabulary. Well, I don't like teaching vocabulary, but it's important to have. Statistics is like another language. Every math class you have, you get more vocabulary, but statistics, you get like whole new language, but you're going to do fine. First, you're going to be fine. Trust me, you'll be just fine.
Okay.
Variables. Now this is pretty much the same thing no matter where you are. But in this case, we're going to say it's the characteristics of the individual. So if my variable is hair color, then we would have like blonde, brown, red, black, things like that. So whatever thing that you're looking at characteristics of, that's your variable. So my variable could be colors of M&Ms in a bag or something like that. So whatever you're studying, the different possible outcomes that has different possible outcomes, that's your variable.
Okay.
Variables vary. If everybody was the same height or plants all grew exactly the same, we wouldn't even need this class and it would be really boring to teach it.
That's true.
Yeah, it gets more exciting after this class, trust me. Qualitative or categorical variables. 99 times out of 100, I will use the word categorical. Qualitative is perfect. You're going to hear qualitative in your homework. I, for some reason, just really prefer categorical. So this is categorical variables and qualitative variables. They're usually words. So this is based on some attribute or characteristic. If they're numbers you don't do math with. So some examples are gender, zip code, hair color, birth date. So these are things that it's numbers you would not do math with. So if I was looking at a bag of M&Ms and I'm like, okay, there's red, blue, brown, yellow, etc. Those would be qualitative or categorical variables. They're usually not numbers. I mean, a telephone number would be categorical because we don't do math with it. So and I mean, sometimes house numbers probably also, because I'm not going to say that person's house, that person's address is two more than mine. Generally, I don't do that. Like, oh, it's even also. So it's probably on the same side of the street as mine. But that's like the only thing. I'm not going to do math with it. Then we have quantitative variable. These are numerical measures. These are things that we would do math with. So examples could be temperature, number of days a student has studied, weight, height, etc. So quantitative data is a variable you do math with, numbers you do math with. Categorical are words or numbers you don't do math with. You will be asked questions about these.
Okay.
There will be questions on, I don't think there's anything on the test. There might be, but there's definitely something in your homework about these.
Okay.
Whether things are qualitative or quantitative. I'll give y'all a moment if you're writing stuff down. I'm gonna take a drink of my tea. Right. Okay. So let's look at these examples here. So this researcher, Elizabeth Kavavic, she studied factors that affect the eating habits of adults, and we're going to classify these. So nationality. The nationality is words like, you could be German, you can be Italian, whatever. That would be qualitative because it is words. Number of children you have. I can have twice as many children as somebody else. I can do math with those numbers. Therefore, it's quantitative. Household income in the previous year. You can say I make 3% more this year than I did last year. I can do math with it. It's quantitative. A level of education is interesting because we say qualitative because if you think of level of education as I have a master's degree or something like that, I have a high school diploma. Those are definitely qualitative. But if you're looking at like what grade somebody's in, you know, like, oh, I'm in 5th grade. So I've been in school 2 years longer than the other person. I'm 2 grades higher. So it really depends. Some things like that you have to think about. Are these numbers I'm going to do math with? So I'm not going to ask you like questions that could go either way. I'm going to try to be clear. Daily intake of whole grains, you would definitely do math with that. That's quantitative. Makes sense? Any questions?
Yeah.
Okay. All righty. Let's give you more vocabulary because we clearly need more words.
Yeah.
Discrete and continuous. You probably encountered discrete and continuous in, you know, one of your algebra classes. I think at RCC, we talk about it, Math 60. If you've gone there, if not, that's fine too. So discrete variables, they have a finite number of possible values or countable. So basically, I'm not going to have 3.75 kids. I'm not going to buy 8.6 tickets at the movie theater. So if it's something countable, it can't take on every possible value between two values. So basically, if I was drawing a graph of it, it would look, If I was drawing a graph, I would have to lift my pencil between each point to draw all the points on the graph because it doesn't take on every value in between. So I have 1 kid, then I have 2 kids, then I have 3 kids. We don't have partial children. I mean, I guess if somebody's pregnant, but we don't even go there. So some examples would be number of students in a class, how many TVs sold last week, number of red marbles in a jar, etc., things like that. So that would be discrete. So discrete cannot take on any possible value. There are not going to be 35 and 5/8 red marbles in a jar. Doesn't make sense. Continuous, on the other hand, it's always quantitative. Both of these are quantitative. And it can have an infinite number of possible values. They're not countable. It can take on every value in between most of the time. So if I was graphing it, I would not lift my pencil when I'm graphing it. It would be a continuous line. If I'm driving to work and I know work is 30 miles away, I have to drive 29.6 miles before I can hit 30 miles. It can take on every value in between. Some examples are heights of a student in class, time it takes to get to school, distance traveled, weight of a baby, things like that. So if it can take on any value, even if I'm like right now I am 5'2" tall, but I had to be 5'1 3/4" at some point before I could hit 5'2". That makes sense. So my growth was continuous. I didn't just jump out of the womb at this height. Any question about discrete and continuous?
I do. So
Okay.
you said discrete. So discrete cannot take on value.
It can't take every value. It's
Every.
and it's not always whole numbers, but most of the time it's whole numbers.
Okay. I think I got it.
The example of it's not always whole numbers. Like let's say that I'm selling t-shirts for $7.50. My 1 t-shirt I have $7.50. 2 t-shirts I have $15. 3 t-shirts I have $22.50. So those aren't integers, but I'm still not going to have $18.75, if that makes sense.
Okay.
But
Okay,
no, I'm
yeah.
not going to give you guys questions like that, but you have to just think about if it's going to jump, it's discrete.
Okay.
All right.
I got it, I think.
Cool. So this is just a little diagram to show that the quantitative have discrete and continuous, and qualitative are off in their own little orange world over there.
Okay.
Helpful or not, it's just a cute little diagram because I like cute little diagrams. All right. So once again, that researcher Elizabeth Kavavic, these are different things that she looked at. We're going to classify these quantitative or qualitative. So number of children, as I already said, it's not going to be, can't take on every value in between. So it would be discrete. Household income the previous year. This is going to be continuous because earning up to, so if you made $40,000 last year, you had to make every value from 0 all the way up to that $40,000. Even if you could always split hairs and say, oh, well, they round to the nearest 15th, quarter of an hour or whatever. Still, it's still continuous. Daily intake of whole grains. This would also be continuous because I had to eat, 15 grams before I ate 30 grams. And, I had to eat 16 grams before I could eat 17 grams. So even though you could take a whole bite and get a whole bunch at once, it's still basically continuous. And I don't really like this example, but it is what it is. Okay, so odometer on a trip, yes, odometer on a trip is continuous because your odometer is not going to jump straight from 1 mile to 100 miles, right? It has to go through all of them. Even though it moves by the tenths of a mile, it's still continuous because it has to hit all of them. Does that help, Quentin?
Yeah.
Okay. All right. So, all right. I'm going to give you my normal, what do I call it? I had a word. Okay. So I always give a disclaimer before I teach levels of measurement. Levels of measurement can be tricky. I am going to give you the way that I remember them. And first I'm going to change my pen to blue because I'm bored of red. But levels of measurement, I'm going to give you my method of remembering them. Even though you're going to have your notes and you'll write notes on them, I'm going to give you my method because it's the only way that I can remember them. Okay. So the bottom of or I guess it's the top because it's at the top of my page. The bottom of the pile is the nominal level of measurement. So these are categorical and they're not ranked in any specific order. Like for example, pulling M&Ms out of an M&M bag, I'm going to have all of these colors, brown and green and red and all those colors, but they're not really ordered. Yes, you might have your favorite colors, but when I list them, there's not a specific order you list them in. So this would be nominal. Here's some examples: gender, handedness, religion, favorite color. So you're not going to say, oh, well, I have to order my left-handed and right-handed. Right-handed always goes first, then left-handed. We don't do that. So if it's categorical, and I'm going to write categorical here. Categorical. If it's categorical and you don't rank them in a specific order, then it is nominal level of measurement. Okay. The next one, ordinal. I mean, the word, it basically says it for you. So it is a categorical, just like the nominal level. However, we arrange them in a specific order or rank them. So some examples, this might help: grades, satisfaction, happiness. So you know that they'll give you like the satisfaction like scale. Are you,
Yeah.
completely dissatisfied or completely satisfied? It's like a range. Or grades, you have A, B, C, D, F. So things that are like ordered, then that'll be ordinal level of measurement. You can rate happiness on a scale. You could even do, for example, like if you're looking at education, you could say high school, associate's degree, bachelor's degree, master's degree, PhD. So those would be ordinal because they can be ranked in a specific order. So these two are the only two that are categorical. I'm going to write categorical here also. The next two are quantitative. Okay, so I'm going to help you with the way that I remember these. So the interval level of measurement. Here is an important piece right here. A value of 0 doesn't mean the absence of quantity. This is the important thing that I look at. And then you use addition and subtraction as the math for it. So think about a temperature is the big one I talk about. If the temperature outside is 0 degrees, it doesn't mean that there's no temperature. It just means it's really cold. And I don't generally say it's twice as hot today as it was yesterday. I would say it is 10 degrees hotter than it was yesterday. So you do addition and subtraction as the math you use, and a value of 0 doesn't mean absence of quantity. The first thing I always ask myself when I'm trying to get these levels of measurement is, does 0 mean absence of quantity? So here's some examples. Sorry. So temperatures, I just said calendar years. The year 0 doesn't mean, okay, time just started. We didn't start at year 0. There are years before 0. Elevation. 0 feet elevation just means we're at sea level. It doesn't mean that there's no elevation, because I can go negative. So this would be the interval level of measurement. First thing you do, check if 0 means an absence of quantity. That is the very first thing you do. So ratio, the ratio level, a value of 0 does mean the absence of quantity. We generally can use multiplication and division with ratio level. I can have twice as much money as you, or half as much money as you. I can have 3 times more money today than I did yesterday. So money is a good one. I use that one a lot. If I have 0 money, it means that there's no money. It's an absence of quantity. There's nothing there. So that's the ratio level of measurement. Here's some examples. Money in your pocket, height in feet and inches. If something is 0 feet, 0 inches tall, it doesn't exist. Weight in kilograms, if something doesn't weigh anything at all, it's not there. If I watch 0 TV, I didn't watch TV. So these are things that are absence of quantity with 0. I can watch twice as much TV today than I did yesterday. Okay, I will pause. Yes. Yes.
So ratio level of measurement is absent of quantity.
If the value of 0 means absence of quantity. So the first thing you're going to do if somebody gives you a variable, if they're asking you what level of measurement it is you're going to ask yourself, if there's 0 of this, does it mean that it doesn't exist or it's not there?
Okay.
So for example, let's say that I'm talking about the weight of a baby. If the baby doesn't weigh anything, the baby's not there. Does that make sense?
Yeah. Yeah.
So that would mean it's a ratio level of measurement. And
okay, I got it.
Yeah.
I understand.
Yeah, perfect. Okay. Cora, let me know when you're ready. Oh, you're good now? Anyone else need another moment to write or have questions about levels of measurement? So the 0 thing is really the thing that, and then, I mean, the multiplication and division, I mean, somebody can be twice as tall as somebody else. I wouldn't really use that. But if you had like somebody who, like a child who's 3.5 feet tall next to a 7-foot basketball player, that person is literally twice as tall as the kid.
Right.
So technically you could use that, but it's kind of weird, but you can. All right.
Okay.
We're going to move on from levels of measurement because I'm over it.
Okay.
Oh, maybe I won't, because we're going to do some math here. We're going to take a look. Gender. So gender, we do not list them in a certain order, and it is categorical, therefore it is nominal. Temperature. Temperature. 0 does not mean. Oh, you feel free to be the class clown, Quentin. I think Eddie's going to give you a run for your money. You go for it. Okay. Temperature. Temperature 0 does not mean absence of quantity, therefore it's interval. All right. Number of days a college student studied this week. If you don't study, it's an absence of quantity. 0 study hours means you didn't study. I do not recommend anybody doing the 0 on that one. That would be ratio. Next, letter grade earned in stats class. Everybody here is going to get an A because you're coming to the meetings. Everybody's going to get an A. I mean, I hope so. That would be awesome. So your letter grade, there's an order to it, A, B, C, D, F. So yeah, see, there you go. How many women do you have? You have 0. That's an absence of quantity. That is going to be ratio. Sorry. Sorry. I'm so sorry. So this right here is ordinal. See, if you guys don't have the comments open, the chat open, you're missing out.
I can see him.
Good. All right. So questions about levels of measurement. Are we doing okay? We doing okay? Okay. All right. So if you're keeping track of that sort of thing, we just finished chapter 1 and you all are still here. You all survived. I don't think that anybody keeled over with boredom. So that's good. I try not to be boring. The first chapter is a little bit tough. It is tough to really show personality on the first chapter, unless you're talking about how many women you have, because, then that it at least brought a little bit of fun there. So we're now in 2.1. We are not staying long in 2.1. We're only going to be doing about half of it. We'll finish the second half on Thursday. So just letting you know, you will not have enough information to do the 2.1 homework after today, but you can do the chapter 1. Please get that done by midnight on Thursday, or please don't use your late passes yet. Save them for later. But that's the attendance. I have to have one assignment due the first week for attendance. That is your attendance assignment. Get that one done, please. All right. So organizing qualitative data. So we're talking about qualitative right now. So first thing, remember, qualitative is the same thing as categorical. And it is usually words or it's numbers we don't do math with. So a frequency distribution. So this is just going to list each category of data and how frequently it shows up. You're going to hear the term frequency a lot. And frequency in this case, we're not talking about like sound. We're talking about how frequently something shows up, how often it shows up, how many of them they are. So when you see the word frequency, you're talking about how many. I'm going to write those words. Woo. How many? That's this right here. Frequency is how many. It's a count. Tally marks or counts or whatever. Okay. Okay. So when we collect data from a survey or an experiment, the data, before we organize it. So if I'm like, let's say I'm pulling M&Ms out of a bag, and every time I pull one out, I'm writing down the color of it. And it's not going to be organized. It's just going to be a big, long list of data. This is called raw. It is raw data because it has not been cooked yet. We haven't done anything with it. It is just the raw data. When you do your lab later this week, you are going to have to list out your raw data. And this is different ways that we can organize it. We can use tables, graphs, or numerical summaries. And don't worry, at the end of this class, I will tell you what kind of data you're supposed to collect. I might even throw some ideas out there because sometimes I can't help myself.
Please.
Okay. So the data on the next slide, it's going to be the color of M&Ms in a bag of plain M&Ms. Don't worry, you're not going to have to write this all down, but I'm going to show you all the raw data. We're going to create a frequency distribution. Here's my raw data. So as I pulled them out of a bag, I just typed out the color. And this is just raw, and it doesn't really do me a whole lot of good, except for the fact that I'm going to use it to count them and to put them in a nice, pretty table, which is right here. You don't have to include the tally marks. I just put the tally marks there as I counted them. So I have 12 brown, 10 yellow, 9 red, 6 orange, 3 blue, and 5 green. And this is nice because it's frequency. This tells me how many. This is this is how many. And that's blue. I need to go to a different color. How many? And then the color is this is just my variable. My color is my variable. Sorry for my handwriting being ugly. So the color is my variable, and the frequency tells me how many of those I have. This is what a frequency table is. It just organizes it in a nice, pretty table. Organizing in this table is going to help me to create some nice graphs. So, for example, we're not quite there yet. I guess we are doing a teeny tiny little bit of math today, but this is easy math.
Yeah.
So relative frequency. Relative frequency is nice because it's going to tell me the proportion or percent of each of M&Ms are in each category. So I can say this percent are green, this percent are brown, whatever. So you just take the frequency, so how many you have, and you divide it by the total number. So this would be how many you have of one outcome. So this is one outcome. So how many brown M&Ms you have. And this would be all the M&Ms. How many M&Ms total do I have? So I take the one outcome and divide it by all of the M&Ms. And when I make it nice and pretty in a table, it's going to be a relative frequency distribution. You will be asked to create these. And I will show you how pretty it's going to look. There we go. So what I did is I took 12, I had 45 total M&Ms, took 12 and divided it by 45, and I got 0.2667. Then I took 10 and divided it by 45 and 9 by 45. And I did this all the way down to get my nice, pretty relative frequency table. And so this is going to be nice because if I had another bag of M&Ms, I might not have exactly 45 M&Ms in there. It could be 48 or 52 or whatever. So the frequency isn't going to be as meaningful. What's going to be meaningful is this proportion of the bag that is each color. And we like meaningful data. So that relative frequency is really important. Makes sense? We're good? Good.
Yeah.
Okay, but so before I do my bar graph, and I'm going to make this pretty again. So in your homework, I believe you're going to get a cumulative relative frequency graph. And this isn't something I like really teach, but cumulative just means add it all up. And sometimes they will give you that relative frequency. So all it's doing is it would take this one right here, and you would have 0.2667. And then the next one would add those two together. So it'd be 0.4889. And then adding this one, 0.6889. And you'd have 100% while you reach until you reach the bottom. So all it's doing is just adding them all together as you go, and it's cumulative. So because cumulative means adding them up as you go along. And so that's what you're doing. And I don't want to math the rest of it. But when I get down here, I'd be at 1.0. I'd be at 100%. This is 100%.
Okay.
Yeah. So you're just adding them as you go along. You will see this at some point in the future, but I just wanted to kind of throw that out there. So somewhere in the back of your brain, store that. Okay. Now we're going to go to a bar graph. Bar graphs are pretty. We like bar graphs. So bar graph. You're going to label each category. And most of the time we do the categories on the horizontal axis, but you will sometimes see them on the vertical axis. And then your other axis is going to have either frequency or relative frequency. That's the other axis of your graph. All of our rectangles should be equal width. And we draw a rectangle for each one. The height of the rectangle represents how many you have or the relative frequency. So bar graphs are mostly used with categorical data. So if you have categorical data, a bar graph is usually a pretty good way to represent it. So you label the category on one axis and the frequency on the other. So I'm going to use the M&Ms. So we have our frequency table. So this is my lovely bar graph for my M&Ms. So on the horizontal axis, I have color, and then I label each color. You have to have labels for both your axes and for the title up here. You have to have all of those labels.
Okay.
So that's very important. And notice the count. So you don't have this one, I'm counting by twos. And you just count by whatever makes the graph pretty. You do need to start at 0. It's not an accurate graph or a good graph if you don't start at 0. I will show you later on something you can do if you're not starting at 0, but for right now, we're always going to start at 0. All right. So this is my pretty bar graph. And we're going to do a relative frequency one. It looks pretty much the same, except for along the side, we have our relative frequencies. But the shape of it is basically the same. So you have your color still on the horizontal, and then you have your relative frequency. And notice how I'm counting by, I'm going up by 5% basically on each one.
Yeah.
Same thing though, same bar graph. Look, we're at slide 33 of 35. We are almost done and we're at 6:30. And I did a lot of just chattering in the beginning. Okay, so finally, I don't know that you are ever going to have a question about a Pareto chart, but I'm going to tell you what it is anyway. I don't think you're ever going to hear this again. In fact, I didn't know a Pareto chart existed until I started teaching this class. So that's how often it shows up. I don't ever remember seeing it when I was in college. So a Pareto chart, all it is you're making the graph pretty by organizing them from the highest frequency to the lowest. So it just looks like this. So it's like stair steps down. That is the only thing. It's all you're doing is just organizing them in a different manner. I don't even know if it's really pronounced Pareto. It's just the way I pronounce it. So who even knows? All right. That was our last slide. We are not done with 2.1. I'm going to finish that on Thursday. Before I talk about what you're going to need for the lab, does anybody have any questions? Realize we're being recorded.
No.
Okay. So for the lab, I'm going to write this on a different screen, and I'm going to pick a different color because I'm weird like that. So the lab is in 3 parts. You're going to need to collect 3 different data sets. I believe the lab itself says 50 of each one. You only have to do 20 each.
Okay.
I've thought many times that I should change the instructions on the lab document, but I decided that I would reward people who are either attend the meeting or watch the videos rather than just jumping in and not paying attention to instructions. So I award you for listening to instructions by saying only 20 each. So the first data set you need some categorical data. And you need 20. And I've had people do things as simple as go to their closet and 20 articles of clothing, they wrote down the colors of them. I've had people open a bag of M&Ms and pick out their M&Ms and do 20 M&Ms. I've had people sit on their front porch and look at the color of the cars that go by. So whatever you need to do for categorical, just 20. I highly recommend waiting to poll your friends and family until later on in the term, because there will be things later that you'll want to use poll your family and friends. So this is not that time, unless your friends and family like being polled, then go for it. Number 2, you are going to need some continuous data. So you need 20 continuous data. This is usually a little bit tougher than the categorical, but because it's not something you can just go and look at all the colors. What you could do is you could go to pick a day and do 20 out of the 24 hours and what the temperature was each hour. You could I don't even know, look at the rainfall and the last 20 months. Trying to think of things that I've seen. You could look at, I'm like really into vinyl right now. You could pick 20 songs or maybe shuffle your playlist on Spotify and take 20 songs and look at the length of each of those songs. Pretty much anything continuous, just do 20 of those. Number 3, you will need discrete data. Remember, discrete data are numbers, and they're numbers that can't take on any value. So you're usually counting something. So one of the things I like to do is you could do something like the scores of 20 basketball games. You could do something like that since we just ended March Madness. So you could do 20 basketball games, look at the scores. I love sports ones. So You could look at 20 posts on Facebook and write down the number of, yeah, see, I need to get a different container for my vinyl. You have, there's no stupid questions, Coral, go for it. Go for it. Okay, while she's typing, I'm going to finish saying, so yes, Quentin, vinyl's awesome. Okay, so just discrete, basically count some things. Count 20 different things. I don't know what they could be. I just lost it. But just, and I like sports scores and things like that. That's a real easy way to get some categorical data, because like for I love football. Football's like my favorite. I could look at 20 football games and talk about the score of those, because I can't have 7.35 points. Okay, so can I use reviews of things like anime episodes? Take 20 people star ratings? Yeah, except for that wouldn't, I mean, I guess you can have a 5.5 stars, I guess, but it's kind of still discrete, because you're not going to have 5 3/4 stars, right? Or 4 3/4 stars. But yeah, you can take the star ratings off of 20 people's. Sure. Shoe size for discrete. Yeah, go for it. Yeah, I like it. Shoe size is great. So you don't have to get super creative, but I will let you know, we are going to use the continuous data for future labs. So if you can make that interesting at all, just because you're going to keep using it, you might want to make it interesting, but it's not that big of a deal. So just try to have some fun. Don't go too crazy, because it's not that important what it is. It's more important what you do with it. But shoe size is great. Any other ideas anyone wants to throw at me before I move on?
Can you, I have a question. Can you do like Facebook, and then are you saying you'd have to pick out 20, say like I posted something on Facebook and then I got so many likes on that?
Yeah, so you could just scroll through 20 posts and see how many likes that you got on each one. That would work. But you
Okay.
would need 20 of them. But yeah,
Okay.
that works perfectly. Go for it.
Okay.
20 posts on Facebook. Yes. So you could just like scroll through.
Okay.
42 different records. Yeah, I love that. Song length is great. I think you need to go shopping though, Quentin. I don't think 42 records is enough. I think you need to go shopping. All right. So, okay. So I'm going to stop unless there's any other questions for the recording. I'm going to stop recording.
Oh.
Okay. Stopping the recording.